there are these things that have different directions, right? There's the force has a direction, the magnetic field acts in a different direction, and those positive moving charges going in a third direction. We're going to represent these things by which way we point our fingers or our hands. Um, and again, we can't just randomly choose which way we're going to do things. There are directions that we kind of have to go. And so actually the image up on top here kind of shows the way we're going to be doing things. Our thumb will point in the direction of positive charge movement. Our fingers will point in the direction of the magnetic field, and magnetic fields point away from north poles towards south poles. And then if we do that, our palm forces points in the direction of the push on charges. So if I had positive charges going up to the ceiling and I had a magnetic field going into the screen, my palm would be pushing on, which shows the direction of the magnetic field pushing on those charges. So the charges would get pushed that way. So it's all kind of a weird deal. And the thing is, we have to kind of be willing to accept the strangeness of this. You have to be ready to kind of take your hand and try to twist and turn and make this stuff work. If you just try to do this all in your head and try to visualize what your hand would do, it's going to be crazy impossible. High school students can't do it. Sorry, it's just the way it is. College students can't do it. You talk to a physics professor or an engineer that's been doing this for decades, they still generally take their hand out and move things around just to make sure they've got it, no matter how many decades of practice they've got in this. So it's just a thing you're going to have to do. So yes, I accept, and I will use my right hand. No, I will not, and I accept that I will lose both this point and probably mess up on future questions. So I'm choosing yes. So from the 17-second mark on that region, which direction would we point our thumb? So when we go to this sort of a thing again, let's see if I can, nope, stop that. So, so if I'm at this point, geez, the screen with the sun out there is not a great deal, is it? So if I'm at this point, there, trying to balance the light. You can see in the backyard trees. What a glorious day. So if I'm at this point and I'm looking at the rod down here, yeah, I just basically, I'm using my right hand and I have to point my right hand in that same direction. My thumb goes in the direction of that rod, goes that way. Yeah, maybe this way the image is a little bit bigger. So my thumb has to go in that direction. Yeah. So my thumb points to the left, the same direction as conventional current or positive charges. Now, in this same time frame, use your fingers on your right hand, not your left. So again, this is the sort of thing where tiny little things can bugger things up. Need to make sure you're using your right hand. So if you're right-handed and you ever find yourself writing stuff down while you're doing these, oops, set the pencil down. You have to use your right hand for this. So use your right hand, not your left, and point your fingers in the direction of the magnetic field. So this is where things start to be arranged a little bit differently, right? So if I have this image here, yeah, and now I know my thumb has to go this way, but my thumb can go this way with my hand pointing a lot of different, with my fingers pointing a lot of different directions, right? So my thumb can point to the left with my hand being in a variety of different positions. But now, in addition to my thumb going to the left, my fingers need to point in the direction of the magnetic field. And we said the magnetic field goes, come on now. The magnetic field goes from, oh, for Christ's sakes, what a glorious day. The magnetic field goes from the North Pole towards the south. So the magnetic field goes to the bottom of the screen. So I need to now point my thumb to the left, and I need to point my fingers down. And so it's kind of this, I need to go kind of like that. Yeah. And I shouldn't have said down. I should have said to the bottom of the screen. So my fingers point to the bottom of the screen and my thumb points to the left. Does that make any, is that something you can follow? Okay. And so my fingers are pointing to the bottom of the screen, the direction of the magnetic field. My thumb is pointing to the left, the direction of positive charge flow or conventional current. So now I need to choose that here. My fingers point to the bottom of the screen. And now when I do that, I need to stand up because this is too awkward to do otherwise. So now my thumb is pointing to the left, my fingers are pointing to the bottom of the screen, and that means that the force on that rod is away from this screen. That way. Yeah. Now, if I use my left hand, all these directions are buggered up. If I change which fingers represent what, everything gets buggered up. So we need to go like that. Thumb in the direction of conventional current or positive charges, fingers in the direction of the magnetic field, palm in the direction of the push on those charges. Um, so I'm going to go, did I already do that? And the palm directed out of the screen. So next.